Welcome to this recording of the Partners 2020 Ask the Expert session for Civil, Electrical and Electronic Engineering. This session was hosted by our careers consultant Chris Trainer, who before becoming our guidance team manager worked as a manufacturing engineer at P&G. We are also joined by guests Lucas Dambitis, Asset Protection Engineer, Daisy Ronn, Geotechnical Engineer, and Daniel Smith, Principal Motor Drives Engineer. We will start off with presentations from each of our guests, followed by a Q&A session where Chris will be leading you through some questions that were submitted prior from you, the partner students. Without further ado, we're going to pass over to Daisy to tell you a little bit more about her career to date.
Okay, hi everyone. My name is Daisy Ronn. I'm a geotechnical engineer at Arup in the Newcastle office. Like Chris said, I'm just going to go through a bit of a background of how I got into engineering and my university experience, a little bit about what Arup does, and then more specifically about the projects that I work on now. So I'm originally from Essex. I got into engineering at school through schemes such as the Engineering Education Scheme, and I studied physics, maths and economics A-levels and an AS in geography. I wasn't really sure what I wanted to do at university. I knew that I liked engineering, I knew that I liked geography and geology, but I wasn't exactly sure what type of engineering I wanted to do. So before I went to university, I applied for a year in industry, and I did that at Arup in Newcastle in the infrastructure and more specifically the geotechnics team. I spent a year there. I absolutely loved it. I worked on a huge range of projects. I got to work with graduate engineers, senior engineers, and it made me really realise that I loved civil engineering and geotechnical engineering, and also that I loved Newcastle. So I decided to apply for my degree at Newcastle Uni to do civil engineering. So when I applied for my degree, I also applied for a scholarship called the ICE Quest Scholarship. ICE stands for Institute of Civil Engineers. Anyone who's interested in studying civil engineering, I would really recommend that you look into this scholarship. Basically, it pairs you with a company. So mine was Taylor Woodrow or Vinci, which is a construction company. I picked that so I had experience both in consulting and in construction. You get work experience each summer. So I worked for 2 summers on Tottenham Court Road Tube Station and 1 summer on Manning Tree Rail Depot. So I got site experience, and then I also got £10,000 cash that they just give you, as well as paying for your work experience. So it's really, really good scheme, and I'd recommend looking into it. Also, whilst I was at university, I studied a year abroad during my 3rd year of university at the National University of Singapore. Another thing that I could not recommend highly enough, like if you ever get the chance to do a year abroad, it puts you outside of your comfort zone. It makes you look really interesting when you're applying for a job as a graduate, something a bit different. You learn a lot, and it's a completely unique experience that I absolutely enjoyed. So after that, I did my master's year in my 4th year, then I graduated 2 years ago, and I started back at Arup, where I did my work experience in the geotechnics team as a graduate geotechnical engineer. This is a picture of me on site on Tottenham Court Road Tube Station. It's about 7 stories underground, working in the fit-out team, which is kind of like what happens after the heavy civil, so lighting, signage, that kind of thing. And then this is me on site in Manning Tree Rail Depot, which was site set up, so it's right at the beginning of the site, like earthworks, things like that. As you can see, we were all women, the engineers on that site, and I think that's something really important to say, that I think a lot of people have preconceived ideas of what engineers are like, but actually when you go to university and when you work, especially when you work in an office, you realise how diverse engineering is, and there's, you know, women, different ethnicities, people who have come through different paths, not just university, to work as an engineer. Outside of work, I like tennis, cycling and travelling. So I'm just going to go through really quickly as an introduction to Arup. So we're a global provider of total design, engineering and business solutions. We have over 15,500 staff members in 90 offices in 35 countries. So what do I mean when I say total design, engineering and business solutions? Arup is split into 3 sectors, so buildings, infrastructure and consulting. And we do a huge range of different types of engineering. So buildings is structural, mechanical, electrical, architectural. Infrastructure, which is the one that I'm in, has civil, so road, rails, bridges, tunnels, marine, geotechnics, which is what I do, and water and hydraulics. And then consulting is more specialist, and there's many different types of engineering that they do in consulting. The next few slides just have a couple of pictures on of like flagship Arup projects that we've worked on. So our creativity is impacting the world around us today, and we have been delivering iconic designs for over 60 years. We're able to tackle the most challenging projects and our thinking is shaping solutions for tomorrow. We invest in our people and support them through their career, such as the Early Careers Group, which I'm part of, and employ enthusiastic and dynamic individuals with the ability to think logically, work well under pressure, and self-motivate. We look for good communication skills to connect with our client and develop a diverse and inclusive workforce irrespective of gender, ethnicity, sexuality, and age. So we have a couple of different steering groups in Arup, such as Connect Cultures, Connect Women, and Connect Out, which look at diversity within ethnicity, gender, and the LGBTQ+ community. So I'm a geotechnical engineer. That's a form of civil engineering which is ground related. So you can be a geotechnical engineer from doing a civil engineering degree, but also from doing a geology degree. And we look at a huge variety of things to do with soil structure, interaction, the way that the ground moves, ground properties. Most civil engineering projects have at least some element of geotechnical design in them, due to the fact that most things sit on the ground or in the ground. So if you think about a buildings project, you've got piles, foundations, deep basements. Infrastructure projects like bridges or tunnels either sit in or on the ground. Then we have more specifically geotechnical engineering projects like landslides, embankments. So whilst working at Arup over the past 2 years, I've worked on a huge range of different projects. Predominantly on HS2, I've spent over a year and a half working on different parts of HS2. So the bottom picture there is ground movement assessments and utilities damage assessments. So that's where we model in 3D the tunnels that run under London, or that are going to be constructed under London, and the effect that they have on the utilities that already exist there. So is there going to be too much strain through a gas pipe that the gas will leak out, or will the tunnels cause joint pull out to water mains and the water will come out? So we're working alongside the utilities providers on that one. I've designed a number of retaining walls in Wales in the valleys. At the moment, I'm working on a flood embankment project for the Environment Agency, where I'm modelling flood embankments around Northumberland, County Durham and Cumbria. The picture on the top is an example of that, where we're letting the Environment Agency know if their flood embankment will stand up in a flood event. Their studies, so that's where you kind of research the history of the ground before you build something there. So if you're going to build a school, has there been a factory there that could have caused a contamination in the past, or is the ground really marshy and it's not a good place to actually build a skyscraper, or are you building something on a medieval burial ground, for example? I've done pile design for some high-rise buildings in Newcastle. And then something else that I'm really passionate about is community engagement, and I'm on the committee in Newcastle. So this is kind of away from geotechnical engineering, but something else that you can get involved with. So I've worked with the SMF, which is Social Mobility Foundation, to bring students into the office, give them work experience, hold days talking about engineering and host different activities. And I also worked alongside Shelterbox, which is a charity that deploys people in emergency situations to build temporary shelters. So these people get sent out to, for example, Tanzania during flooding and build a shelter, but they're not actually engineers. So Arup and Shelterbox worked alongside each other to produce a 2-day course to teach the people who are deployed really basic engineering knowledge, just kind of things like triangles stronger than a square, and good ways to build foundations, and good ways to tie different materials together. So that is just a really quick overview of what I do at Arup. Ask me any questions at the end, but more specifically about civil or geotechnical engineering, anything to do with work experience, whether that's a year-long work experience or summer work experience. can't really advocate enough how important work experience is, and not just in terms of putting it on your CV, but also letting you know what you like. So I worked in both an office and site, and I would have always thought I would have preferred working on a site. But actually, after doing both my work experiences, I realised that working in an office I much preferred. Anything to do with year abroad, living and working in Newcastle, or just Newcastle University in general, and societies. I was a member of a lot of different societies at the university. Okay, that's me. Thanks.
Thanks, Daisy. Really interesting. Great. So, Lucas or Daniel, any preferences? Who wants to go next?
Yeah, I'll go next.
Great. Over to you.
Right, good afternoon, everyone. So obviously this is the presentation I'm going to do for the Partners 2020 scheme. It's a bit different to Daisy's. The fact that most of it is just mainly pictures of me, because I like using pictures, because then if I mess it up, then you don't know. So obviously that's me on there. I studied Civil Engineering Integrated Masters at Newcastle University. I completed this in 2016. Again, like Daisy, I was a Quest Fellow of the Institute of Civil Engineers, partnered with Network Rail for the whole time. So I did 3 placements, and I cannot stress enough that it is such a great scheme for civil engineers. I think it's because it's advertised before you actually start university. It's not that well taken up, but it was a fantastic experience. I actually learned so much from the job, and from that I transitioned straight onto the engineering graduate scheme with Network Rail. Luckily, didn't have to go through any interviews because they'd seen me work over summer placements and I got good reviews from my managers. So I just took a little bit of stress off in that final year, knowing that I could just focus on my studies. And the financial support as well is fantastic if you do civil engineering. And then from there, my first appointment within Network Rail is as an asset protection engineer for HS2. So I still work for Network Rail. I'm essentially a custodian of the railway and just assess all the interfaces with HS2 and ensure that that's not going to damage our infrastructure and the operations. And then recently, just last month, I was successful in applying for a Rail and Rail Systems Principal Engineer Level 7 degree apprenticeship, which will take me 3 years and means that I'm going back to Birmingham in 2020 to start studying further MSc. And finally, I'm an avid sportsman. I watch any sport from ostrich racing to extreme origami. But day to day, I'm on the found playing hockey until in London most Saturdays. So Network Rail, if you know anything about it, so basically we own and maintain and operate all the rail infrastructure within Great Britain. So that's maintaining the tracks, signals, all the assets which go with it. In the company, we have about 38,000 employees. So that means there's such a wide variety of roles. And during my time on the graduate scheme, I had a chance to try a lot of these out, whether that's within engineering or even within the wider business. And these are furthest from some of the highlights. So I was part of a drone trial to look at how we could use LiDAR scanning to assess how earthworks are slipping. And then probably my favourite time was spending a week with our internal air operations team. So we've got these helicopters which go out with LiDAR scanners. You can see there's a heat sensor which basically looks to see when parts of our infrastructure, especially the electrification side, are getting hot, so it's starting to fail. We can pick those up and maintain them before it fails. And these 2 years on the graduate scheme allowed me to transition from working, being in a university environment to the actual working world. It was a really good 2 years to help me go in there and pick up a lot of professional skills. Even outside of university, I've not stopped studying. I think that's part of being an engineer. You need to keep on building skills. You never know everything. So we do a lot of practical days on the job, practical learning. So going back to surveying, which I hadn't done for 2 years before that being at university. I studied a further diploma with the Permanent Way Institution on track engineering. And I'm working towards chartership with the ICE, and hopefully we'll be going for my professional review in March time. And then, of course, I'm going to go and start studying a rail and rail systems integration MSc at Birmingham, which is part-time, so still be working. So when I was thinking about what I can show to my current role, I mean, fortunately, I was out on site yesterday at Euston, and this picture sums up perfectly what I do day to day. So this is part of the HS2 project at Euston. That's one of the towers outside the front of Euston Station on the piazza. Demolishing it is 15 stories high. You can see they've got down to slab, which is 3 meters thick, and that's just pure concrete and steel rebar. It's quite magnificent seeing it, and I think it was so unique just for scale of it. It was built in the 70s when they didn't quite understand how to be efficient in design. So the rebar on that is insane. But that is next to a live station. Euston Station has 42 million passengers passing through it every year. Right behind the demolition there was the Virgin drivers' restroom where they go for a nap, they need to sleep, and while we're breaking out that massive concrete, so we have to assess the damage of that. Yesterday we had a 450-ton crane in there to lift out these 45-ton excavators, and all this is going on in a live station environment, and every day it's quite amazing to see this happening, and my role is to ensure that the public who are walking past that is safe within that, and they actually don't notice that these works are going on. So as part of the brief, we were asked to identify how my time at university has helped me in the workplace. Easily the thing which I've gained the most of is learning presentation skills. Before I went to university, hated presenting anything, hated standing up in public. All that just sent shivers down my spine. But my laziness actually helped me here. When I got into doing university group projects, I realised that no engineers like presenting, and if you wanted a bit of an easier ride through doing group projects, put your hand up to present, and people happily let you do that. But from that, I've learned, in the workplace, the skills are used every time. If you're presenting to a single person, if you're presenting to your team, all the way up to I've presented in front of a conference of 100 people. All the skills are interchangeable, and the skill set is always developing. Every time you do a new presentation, you have a chance to refine those skills, try a different thing. And now I leave a chance to do presentations like this, like going into universities and doing talks, doing stuff like outside of work. I find that's just help boost my confidence in talking in public. And that leads on nicely to talking about technical versus non-technical communication. Again, at university, you'll be going primarily just technical within your course, but sometimes have a chance at talking to your flatmates about a concept in engineering, whatever stream you're doing, just to practice that and see if you can get across some of the ideas. The example that I've got on the screen here is, so in our first year on the grad scheme, we were asked to organise a stand at the Big Bang Fair. The Big Bang Fair, for people who don't know it, is a STEM event which they do them across the country, tens of thousands of students and teachers coming through. The idea is companies come along and help inspire school-age children from the age of 6 up to 18 to start studying STEM subjects. So first of all, it's a really good way of feeling fulfilled and passing back to the community, to education, to help bring people up and make them excited in STEM subjects. Also, you've got to present your information in a way that that they can understand, but also challenges them. So that skill is something which is really important. And in my day-to-day, sometimes I'll be talking the concept to engineers who want to know the finite detail, want to know every single little bit down to the technical specification. I'll be talking to project managers who want to know the ins and outs, but don't have that same background knowledge. So you've got to tailor it a bit. Going to stakeholder meetings where actually all they care, it's people, Joe Public, who all they care about is how it's affecting them. And if you can communicate them in a non-technical way, you can really make a difference to people in the community. Especially like a lot of stuff we do at Network Rail, it's highly disruptive. HS2 is highly disruptive. Having that non-technical language and being able to alleviate some concerns without spewing a bunch of jargon at them is really good, and it will really help your career. The final bit is, so whenever I do a presentation which involves talking a bit about my career, I get shocked at how many years have passed since I've been to university. Every year it seems to creep up on me. And you'll see from the photo on the left here, that's when I handed in my research project outside the Cassie building, which ended up being 87,000 words and 13 days late due to being in a personal accident. And every time I look back at that, I just think that was such a massive achievement that I managed to do it. I look at that photo and I think about all the bad times, all the good times, how well achieved I felt after handing that in. that just goes back to the fact that it's so important in work to reflect on what you do in your project that you've completed. And again, that goes into university, reflecting on what you've achieved and what you've created is important, because you can work out what went well and develop on that. You can work out what could have been better and change it in the future. I think that's like not regret per se, but I wasn't very good at reflecting at university. When I had reflection reports, I'd do my minimum on it, and I wish I would have put more time into it, because now I'm in the working world, I can see how much that actually means to you. Like, if you can reflect on how you work at work and see your strong points and maybe your less strong points, you can push your career so much further. And I think the important thing is for everyone on the call is you should reflect on the individual journey you've gone to get to this point, being on the partners program, and just take pride in what you've achieved so far, and hopefully you'll find yourself in Newcastle in a couple of weeks. And finally, thank you very much for listening, and best of luck with what you do going forward, whether it's in Newcastle or not, and what you do in the future. I think this has been shared before, but my LinkedIn's there if you want to talk about anything regarding rail industry, network rail, HS2, anything regarding Newcastle, please feel free to get involved. I would highly recommend looking at a career in railway. Thank you.
Thanks, Lucas. That was fantastic. So yeah, two really interesting presentations from civil engineers and different directions of civil engineering, but a really nice contrast there. I think it's about time we heard from electrical and electronic perspective. So, are you still with us? Would you be able to kind of take us through your own story, please?
Yeah, hello. I'm going to feel very old now, because from what Lucas said, I finished my undergraduate 12 years ago, in 2008. And that's when I moved up to Newcastle to do a PhD. So I grew up in Northern Ireland and went to school there, but came over to England to do my undergraduate studies. I was interested in engineering, which was a bit of a break from my family. My father was a geographer, and more a sort of a geological geographer, so in line with the civil engineering, but that wasn't for me. I like big bits of spinning metal. I like electrical things. I like making stuff. So I ended up doing an engineering degree, and funny enough, Chris, I had a job lined up with Procter & Gamble in the Northeast, but I passed that over to do a PhD at the university, which was just a bit more me, found it a bit more interesting than what Procter & Gamble were offering. So hope that doesn't offend you. So my PhD was in the electric motors. So I had very much a blank sheet of paper request from an external company saying, we want to make some very high power electric motors, and we want to sell them to the United States Air Force so that they can test some of their future plane engines and future plane designs on. So no one in the world was making these motors of this specification. So we saw a great research opportunity to try some new things, try and push the boundaries of what could be done in an engineering sense, so new materials or new designs, or coping with the fact that they get very hot. And that ended up being quite successful. So I took a lead as a designer with the academics guiding me. So I designed these electric motors, and we ended up making a couple of them and selling them and putting them into some Air Force bases in America. So I got to go out there and help install them and test them. So that was quite a nice trip. In terms of what they are, they're a megawatt electric motor. So that's sort of 2 Formula 1 engines of power, and we compressed it and made it very power dense. So you're effectively trying to squeeze a Formula 1 engine into your school backpack. So it's a very, very power dense motor system, and required a lot of very, very fine detail engineering to make that work. So we made it work. Of the 4 that we sold, only 1 blew up in quite spectacular fashion with flames shooting out of it and everything, but we were able to sort of fault trace that and build a new one and replace it, thankfully. But that was the sort of some of my PhD. So that was a 4-year engineering doctorate with very hands-on engineering work and design, and got to build something practical at the end of it. So that's very good. And I was very lucky to sort of choose Newcastle to do that, because Newcastle is one of the really good electrical engineering places left in the UK. There's a couple of other institutions which I won't name, but I would say Newcastle is one of the best ones. It's got a great course, and it's got some really good academics and a great background, great history to its work. So after my PhD, I then moved to join Dyson Technology. So I assume most people know Dyson. We make the vacuum cleaners, we make hair dryers now and fans, and we're moving into lots of other sort of beauty products like straighteners. So that's all coming out in the market now. So I joined as a motor drives engineer. So I spent the early part of my career designing a big electric motor, and then I was asked to design much smaller electric motors, but similar challenges, just a different scale. Dyson have a very strong link with Newcastle University. A lot of some of Dyson senior management and a lot of their electrical engineers have graduated from Newcastle, so we have a very close partnership. We actually have a research office based in the university where I am based full time, so I manage that office, and we have a few staff there usually, and we have a bunch of PhD students, and we get involved in undergraduate teaching as well. So we're heavily linked to the university, and I do a lot of supervision of that link and product. And sort of whilst at that office, my main role over the last few years has been designing the electric motors for the Dyson car. So I'm sure people might have seen it in the press. Dyson was making an electric car. They've since shelved that project for economic reasons, but I was sort of the lead engineer who designed the electric motors for it. And I'll get onto that in a minute, a bit more detail. But since that's been shelved, we've moved on to, and we've managed to get a lot of money out of the government, sort of £5 million over the next couple of years, to set up a new research lab in Newcastle in partnership with Dyson and the academics. And we'll be looking at just how to make your domestic products smaller and more efficient, start looking at some of the nasty materials that we use in electric products nowadays and trying to minimize their use, make them more environmentally friendly. So we really see that as laying the groundwork for the next 10 to 20 years of domestic products, making them more efficient, smaller, cheaper, better for the environment. So what I thought for you guys is things about engineering as a career. One thing that was never really explained to me when I was looking at engineering was, what do engineers do day to day? Are they sitting there with a spanner and tweaking nuts and bolts, or what are they doing? So based on my own career at Dyson, I've jumped through several levels of job now at Dyson. I'll just sort of give a bit of a summary of what an engineer does at Dyson. So I came into the company as a motor drive engineer. That's a very generic engineer, just a few years after graduating effectively. And in that sort of role, you'd be given small research projects to look at. So you might be asked to say, look at the components for this motor, and we've got a new supplier in China who can make it a bit cheaper, but it has slightly different behavior. So can you see if it'll work for us? Or we've found another type of electrical switch that can control our systems and divert power through our systems, but we're not sure if it's going to be good enough. So can you do some simulations or some calculations to see if that will work for us? And a lot of the time, certainly within these projects, you spend time building up your knowledge base, building up your contacts and your experience within the company. And from there, you start to pick up all the common tools and things that the company would use. So you often take the learning that you pick up at undergraduate, which is vital to understand how these things physically work, and then you'll sort of reform it around the tools and procedures that the company uses or prefers, because there's lots of different ways to do it, and each company has its own way of sort of approaching these problems. But without the sort of undergraduate level experience, or just say that the power switch I've shown there, if you don't know how that works from an undergraduate level, which is what you would learn if you came to Newcastle, you'll struggle to sort of design anything using it or optimize it. So from that sort of generic introduction to your engineering career, as you come out of university, you progress to be more of a senior engineer, and that's where you'd be expected to take a bit more of a sort of personal leadership role within the company. You might be leading a team of a few engineers working for you, and you'd be handing out their workloads and assessing what needs to be done. So my experience as a senior engineer was I was a technical leader for the electric vehicle motor design. So I was asked very much to say, well, what should we make? What should it look like? And how will we optimize it? And then how does it compare to everyone else? So that was my job in leading that electromagnetics, but then collaborating with all the other teams that I might work with. So there's a little image there on the side of the powertrain that we came up with, which is the electric engine for an electric vehicle. So I was designing the motor side, but it had to be coupled to a gearbox to get the speeds right for the wheels. And then it also had to be connected to a very complex set of electronics to take the energy from the battery and send it through the motor and create the right sort of speeds and torques that you wanted to drive the car. So that was my role, was to design the motor, but also collaborate with everyone else. So you're sharing a lot of information, you're controlling the information that you're responsible for, and making sure people use the right data or the latest design and things like that. So there's a lot of sort of like a gatekeeper of information. And now I've progressed on from that to more of a principal engineer role. So it's quite a senior role within the company. Beyond there, it would be heading up into directors and leading strategy for the whole company. But right now, I'm more sort of a technical engineer who I look over an awful lot of projects. I'm responsible for reviewing a lot of people's work and making sure they're doing the right thing. Probably I come back to them and say, no, you've probably not thought about that properly, or you've missed that thing out. Can you go back and redo it, or can you double check that, please? So that's sort of my role now. And the other thing I'm heavily responsible for now is coming up with new ideas. So we say, well, there's an opportunity here. Why don't we redesign this, or why don't we create a new product that can fit this part of the market? And then we sort of present all these ideas up to the board. So there's a little image of me there in the corner presenting some of our latest electric vehicle designs to James Dyson. So this was tested in Newcastle University. This is a high performance testing lab within the electrical engineering department where we can test electric motors, and James came up to see our latest designs a couple of years ago, so I had to jump on the rig and explain how it all works. So it might look like I'm doing a funny dance there, but I'm actually pointing out some very important technical things to James. I just thought, for those who don't know, I thought I might just talk about electric motors in general. And I'm a big electric motors nerd. I really like them. I find them really, really interesting because everyone is different. You go to any particular application or any particular designer and they'll come up with a different design. And I love trying to figure out why and what the differences are and why has someone done that and not done something else, or what's the reason for this being so small or this being too big or not being efficient enough. So certainly at Dyson, we're very interested in taking our designs and just pushing them, getting them most we can out of the materials, controlling them more effectively, and getting them faster and smaller. So this is an image of a Dyson electric motor. It was one of our 100,000 RPM motors, very, very small, very, very fast. We power our vacuum cleaners with. So we have a bespoke fan that gets really powerful suction. And then we support it on a set of very high-speed ball bearings that we have to engineer very carefully so they don't wear out. And to create the power, we have a strong magnet right in the middle, which is attached to the shaft, and it's that magnet that we try to spin. And we spin it by placing electric currents through some copper wires arranged around the magnet, and we pulse the currents in those wires to pull it around. And finally, the whole thing is encased in a plastic frame, whereas typically motors are in a metal frame, but we've gone for a very strong plastic frame that brings the weight down and makes it good for the user to hold in their hand. So if you don't know just how those motors work, so there's a little image there of a motor with some little grey teeth on it and a little bar magnet in the middle, a north-south magnet. So we have a magnet and we try and spin that magnet around in place by creating a new electric field on the teeth using some copper wires. We pulse current into the teeth. It creates a magnetic south pole on the tooth and pulls the north pole of that magnet in line with it, as I've shown there. And then we move to the tooth on the left, put a current in there, create a south pole there, and pull the magnet around. And we just keep pulsing that around, pulse, 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 all the way around to keep the motor spinning. And this is certainly not a new technology, but we've miniaturized it to a great degree. So down below is an electric motor that works exactly the same way, and that's in one of the museums at Newcastle. It's designed by Parsons. It was designed 120 years ago, but it works in exactly the same principle. It just doesn't have the miniaturization, the speed, or the good materials that we have nowadays. So I think I'll just wrap up because I know we're getting on with time and there might be time for questions. So I just thought I'd give a quick sales pitch on the last slide about why I think engineering is a good career and how university can help with that. So the world always needs engineers, always need people to get stuff working, and we need people to keep it working when it goes wrong or to make it better. So engineers are in quite a lucky position. You get to know how everything works, and you'll always be in demand if you know how things work, because a lot of other people don't. And I think that's quite a powerful position to be in. My nightmare scenario is if everything goes wrong in the world, people are going to turn to those who know how stuff works to get it all working again. So that's quite a powerful position to be in, I think. The interesting thing, certainly from electrical engineering, is there's not enough engineers around. We need about 30,000 new electrical engineers per year just to cover retirements or people moving on or new opportunities coming up in the industry. But universities are currently only training about 5,000 per year. So there's a huge gap in the market. It makes you very desirable as a graduate to come in. And finally, certainly salaries are pretty good in the top end of the engineering sector. So you can get paid like an NHS consultant. You can have your pick of jobs. You can go into quite a large stable company like I have, or if you're more interested in fast and dynamic things, you can go into a startup. And finally, you can go anywhere in the world. Engineering is done in every country in the world, and all sorts of things are done. And I'll wrap it up there and we can get to questions if you like.
Thank you very much, Daniel. Really interesting. I think your love for electric motors is infectious. It got me thinking about it as well, and I think a really good explanation there.
Thank you to Daisy, Lucas and Daniel for those excellent presentations on their career so far. We hope you found the information useful and insightful, and we now lead into the Q&A portion of this session. Our careers consultant Chris will be taking our guests through some questions that have been previously submitted by you, the partners students.
I thought I'm going to kick one off to start with. So in both disciplines, the civil engineering and the electrical electronical engineering, I think you you've shown there's a lot of variety of options out there. So you can, I mean, classically, when students from civil engineering come to speak to me in the career service, they say things like, I know there's things like consulting and contracting. What are the difference, and what one's right for me? Equally, in your cases, Daisy and Lucas, you've got different sectors that you're operating in, as well as that sort of functional difference. And Daniel, I guess, again, civil electrical engineering, there's a lot of different possibilities that students can move into after graduation, different sectors, different industries, different of functional specialities. Just interested in each of the three of you, how you came to the decision that you did as to why you ended up in this particular branch of your discipline.
That's an interesting question, because I did a general engineering degree, so I did a bit of everything down below and when I was an undergraduate, and that sort of showed me what was out there. So I did beams and structures for civils. Wasn't particularly good at it compared to you guys, I bet. So I ended up picking a career that sort of let me try a bit of everything. Motors and electrical engineering allows that, because electrical engineering might seem like circuits and transistors and things like that, but if you ever want to make it really good, you start having to think about the thermal engineering, because everything's going to get hot. You have to think about how you're going to assemble it and build it. So the mechanical engineering and tolerances comes into it. It all starts feeding in together once you get into pushing the performance of things. So that really interested me, and I was very interested in sort of a problem solving career, and my choice with Dyson allowed me to do that. So it was very much my job as a problem solver for the company. So if that sums it up.
I think from my side, it was work experience, really. Like, I did a real broad range of work experience, which allowed me to realise what I was more into. So kind of like I touched on in the presentation, that I thought from being quite outdoorsy and hands-on that I would like to work on building site. But actually, when I tried that compared to working in an office, me just felt like I was using more of my technical skills that I'd learned at university in the job that I do now, and I felt like a lot of that working on site was more like management skills of people almost. So that's how I felt in my job, and I just felt like, especially at the beginning of my career, I would want to focus on the technical skills more first. But also, a lot of the projects that I work on are very multidisciplinary. So similar to Daniel, that even though I'm a geotechnical engineer, I work with a structural, mechanical, electrical engineer in a project. So you still get a taste of all the different types of engineering.
Yeah, for me, so it's all about contracting and consulting, but I sit in a smaller bit, which is working for the client. So now at Crail, we all our work goes out to the contractors and consultants, and then what we do internally is we review it and we manage it from the engineering side. What got me into Network Rail really was the fact that there's so much investment going into railway. Every day we're dealing with, we've got assets out there which are 150 years old, and then we're also building a brand new railway, and everything in between. And I think, so yeah, I did a 6 months secondment to Mott MacDonald as well, who's a consultant, and I hated it. I hated every minute of it. It really made me realise that I like being out on the ground, where I put my head to ground, especially working for Network Rail. I'm now transitioning from being a civil engineer, and doing this additional MSc will change me into a systems engineer. Because in Network Rail, you've got every single strand there all trying to work together in the same patch. So you get like a more autonomous view of the engineering side of it. So that was my thinking behind it.
Thank you. Yeah, useful. One question that came through in advance, actually, from one of the students was about the distinction between your MEng and the BEng plus MSc option later on. Obviously, it's a very personal choice. People who are thinking about chartership or not thinking about chartership, there are implications about your master's level qualification. But just interested in everybody in the call, what your thoughts are on the pros and cons, perhaps, of why students might want to think about one route versus another route.
I would say that there are more specific MSCs. So if you really feel like you want to do something really, really specific and you want to do that, then you could seek out that MSc. And if you've done a BEng, then you can do the MSc in a different university, or you could have a break and then come back. Whereas MEng, for me, I picked it mostly because it's just easier to sort out. Like, I know it sounds stupid, but like all your student finance, everything, you just go the whole way through. Actually, the last year and fourth year with a MEng is shorter than with an MSc, and you won't have to write 2 dissertations because you'd have to write a BEng dissertation and an MSc dissertation if you split them. Also, you can't do a year abroad on this course without doing an MEng, because otherwise your final year would be abroad and you can't do that. So I wanted to do a year abroad, and that's why I picked an MEng.
My thoughts behind doing an MEng was just straight away I knew I wanted to do it civil engineering. I wanted to be a civil engineer, and I loved, when I was looking at Newcastle, I loved it, and I thought I definitely want to be there for 4 years. I think the important thing is, especially, I don't know what it is with the other engineering, but in Newcastle with the civil engineering, it doesn't matter which course you're on. Like in your second year, you can choose to change it. So I wouldn't worry too much at this point. Get a flavour of the course, and either way, you've got a chance to change it. But and again, so I did MEng straight away. I went into work, and now I'm doing an additional MSc. So even if you're worried, if you think you might want to do something specific, there's always that chance later on. Like it's not a make or break decision now. So just go with what you feel like.
Yeah, sounds good advice. And Daniel, because you did a PhD, so again, I don't know if you have reflections on that about the pros and cons of that option and what implications that's had for you.
Well, yeah, that's quite interesting. I did an MEng, but that was because I had no choice, and my undergraduate degree was always going to be an MEng. But I am now involved in quite a bit of recruitment. Sort of, I recruit PhD students, and I help Dyson recruit staff down at Dyson. So I see a lot of people with a wide range of degrees, and personally, from our point of view, it doesn't really matter which way you pick. It's about the person. So I just echo Daisy's response. An MSc does give you the chance to maybe specialize in something a bit more, but it's a bit early on to maybe be taking a punt on exactly what you want to specialize in until you've maybe had a try and seen some things. So we see a lot of people who've done a BEng and then come to an MSc, and that's because they've been sent by one of their other employers. So they might have had a sponsorship scheme before from the National Grid Company of Saudi Arabia, and that insists that they come to Newcastle to do an MSc in power grid engineering, that sort of thing. But if you're just considering engineering as a degree, I would come in and do an MEng, and then you always have options later to, as Lucas says, change tack if you find something's more interesting or not to your taste. I wouldn't worry too much about it, but an MEng degree is always good, but if you're a good person, we'll take you with just a BEng on a recruitment perspective. There are plenty of good engineers who didn't get past BEng, and I know academics who don't even have a PhD. They're just really, really clever.
Yeah, absolutely. And I think that sentiment is echoed by a lot of employers that we work with as well. And it is a very much a personal decision, and that view is, I think, has been mentioned, will probably change and evolve as you kind of progress through your degree. So, short answer, a bit of advice from me would, if you're in that position debating it either in first year or in subsequent years, speak to one of the team in the career service, and we can try and have that conversation and help you think about the pros and cons and what might be right for you. So yeah, great. That kind of covers that one. Next question is a bit of a two-part. I hope the first part's the easier part, and it's what aspect of your role do you find the most enjoyable, the most rewarding? And I suppose the flip side to that is we often hear from employers all the good parts of the job, but I'm also interested in what are the tough parts. What are the bits that you find most stressful, most frustrating, most difficult in your role, warts and all? So a two-parter.
My answer would kind of be the same for both, I guess. It's the work that I'm doing now, especially tunneling work, is very complicated, and it requires you to remember a lot from university, and it's difficult, and you work with big groups of really intelligent people. And on one hand, when you get things right and you problem solve, it feels so good. And when you step back and you finish the project, you think, wow, I can't believe I did that. You know, thinking about when I started 2 years ago, I'd look at people doing my work and I'd think, how are they doing that? And now that's me. And at the same time, I don't know, sometimes you just feel like, oh God, like this is too hard for me, like you're in too deep. But, you know, it always gets worked out in the end. And like, it's really good working in a team full of really intelligent people, and you grow a lot and you learn a lot. And you kind of get used to the fact at the beginning that you might feel like you don't know what's going on, but I think everybody feels a bit like that at the beginning, and it's really rewarding.
Great, thank you.
I think in mine, it's like Network Rail as a client is seen as very difficult to work with. When I speak to some contractors, when I was on IP, like our infrastructure project side, anyone tendering for a Network Rail project would put Network Rail tax on it, which would be another 20%. So I just knew it was going to cost them extra time and money. So for me, I think the most satisfying thing is when we work with our stakeholders now. So some of the contractors where we review their designs, HS2, it's how we work as a team, myself and them, and how we're given like a positive image in terms of how we work with them, communication lines. I think I realized from this, I'm instinctively very good at getting people to call me up. A lot of people won't pick up the phone. I mean, that really frustrates me. If you're trying to get in touch with someone, if they won't pick up the phone or reply to emails, I'll always be at the end of the phone and happy to talk to people. Again, like if people want me to go to site and have a look at something, I love going to site. So I'll always be out there, first one there to get my PPE on and go and walk the tracks and see stuff, whatever weather. So I think building relationships at work's like what is like my favorite part, like how you can see that develop. And like I've been in this role for 2 years now, and it feels nice that you have like a trust network with people you're working with. You can talk to them and stuff, because once you start losing trust with your contractors, your designers, then it makes your life so difficult if you can't get the right information out, and then things crop up at the last minute and it'll really trip you up. So I think my most important bit is building relationships within your organisation and others.
Thanks, Lucas.
From my perspective, the best bit about my job is doing something new challenges that come along. So I'm very much, I get given a problem and I get to solve it, and I really enjoy doing that. So as an example, I can't tell you details, but we have a new product concept, and people have been trying to make it work and been buying off the shelf components, but they're not very efficient and they're really big. So if you've got a battery connected to it, half the energy in the battery is just wasted as heat, not actually doing anything useful for you. So we look at that and say, well, if we did it ourselves, we could make it 4 times smaller, much lighter, and would only sort of lose about a quarter of the battery energy. So it would be a smaller, lighter, more efficient product that lasts longer. So that's really what we enjoy doing. And we'd come at that from a blank sheet of paper and say, what's the best engineering solution? So I really like doing stuff like that. The biggest challenge I find in my job probably is communicating with other people in the different ways you need to communicate. So if I'm working on a multi-team project, you have to share information between different people, and managing that can get quite stressful because different people know different things. And the other side is probably presenting information up within the organization. So presenting information up to the board of directors is very, very fraught and can lead to a lot of late nights, making sure the information is exactly right and you're not going to get called up on anything that's wrong. So this is very, very picky. You're going to be very, very precise. So that's some of the bigger challenges. So.
Great, thanks. I appreciate the thoughts there, everybody, the honesty as well. Okay, so I think we're coming towards the end of the time. So there's probably one question I wanted to just squeeze in before we wrap up. It's quite a brief one, and this is something actually we're asking to the different subject streams. We're going to try and collate responses and best practice here, and it's quite straightforward really. So to each of the panelists, considering your own time at university and your own career, what one bit of advice would you like to share with partner students as they think about approaching their new university lives?
I was going to say, just make the most of university in terms of like, take every opportunity that you possibly can. I think when you speak to people when you graduate and you say, oh, what do you wish you did? They always wish that they'd joined the society, or they always wish that they'd done a year abroad. And I think like the university has a lot to offer in terms of career service, year abroad, year in industry, societies, making friends. You know, put yourself outside of your comfort zone, because you're only going to be there for 3 or 4 years, and once that's over, you're not going to have those opportunities again. It won't be the same. So do everything you can.
So I'll just echo that. So that's what I say to PhD students is suck the marrow out of it. So you got one shot at this, and you're effectively getting paid to go and learn, get new skills, teach, and try out all sorts of new things. The university brings so much stuff all together in one place for you to access and enjoy and learn from. So just go for it. And in line with that, as an engineer or as an engineer learning, I think the biggest piece of advice is don't be afraid to fail. So a lot of people get really, really flummoxed or get really nervous if the task in front of them doesn't fit what they've already been taught, or they don't quite see a way through it. But just have a go. You might not get it right the first time, but you'll figure out what you need to do differently and you'll get it right second time. So most of the work I do is never right first time, but I can see where I went wrong on reflection and I can fix it, and then it's ready to present. So just don't be afraid to have a go, even if you might not get it right, because no one's judging you. They're there to teach you and help you learn and grow.
I can echo all those sentiments as well. Like I believe the university was such a great experience for me. Like I saw myself change a lot, saw myself come out of my shell, learned a lot about engineering, and really paved a good start to my career. The other thing is just never stop learning. Like from being in engineering, like as part of chartership, you're expected to do CPD, and I think my favorite bit is studying about things which might not be directly involved in my actual role, but like just pushing the boundaries a bit, like looking into stuff like what Daisy does, like geotechnical side, nuclear stuff, and just always finding. It's always great when you can find a little bit of passion outside your work, which just helps you grow a little bit more. And if you find the right passion in learning now, like it'll really help you going further on, just to keep your career growing, yourself growing.
Thank you very much. Yeah, I mean, we'll come towards the end to wrap up now, but just 3 very, very illuminating stories and some very useful advice there, and very grateful for the time, and we're very lucky to have that sort of diverse panel, and points that have kind of hit home, I'm sure will be very helpful to those watching back. So thank you very much. I appreciate everybody giving up the time for today. Much, it's very grateful.
Thank you for tuning in to this recording of the Partners 2020 Ask the Expert session. We hope you found the discussion and the presentations from our guests useful and insightful. Remember to stay up to date with further advice from alumni and industry professionals. Subscribe to our Newcastle University Career Service YouTube channel, and you can follow us on our social media channels at NCL Careers on Facebook, Twitter and Instagram. We hope to see you in September. Good luck and take care.